Hi everyone, Ethan again. Last time I uploaded a video about the quantum double slit quantum mechanic experiment you can make at home, and people asked me about it. Uh, what can you do with it? What's the application of it? Um, so here's the idea I want to talk about. It's called quantum mechanic predicting the system failure. Um, so here's the idea. Suppose you have an app server, you have an application server, and you have a database server. The user give the request from the application server, and the request go from the application server into a database server and to do something, right? So this pathway from the application server to database server is critical. You don't want this pathway to be broken. If this pathway is broken, you're gonna lose traffic. You probably lost your business as well. Um, so you want to have a lot of sensor to protect this pathway, right? Similar, this is a very useful use case, can be applied on many other places as well. This is how we do it today, right? We can use data pattern to do some data mining or data discovery. We saw last time when it broke, it's because of the high CPU. So we have a sensor over there to detect the CPU usage. If the CPU keep going up, if reach a threshold, we're gonna throttle the system to protect this pathway. This is how we do that today, okay? Now I want to introduce a different way of doing it. Um, Before I introduce this, I want you to look at the video that I will be uploading in the comment. Those two videos are critical for you to understand quantum mechanics or double slit experiment. Let me just do a quick remind here. So, you can see me here? Cool. So for example, if I have a photon going through a double slit, if this photon behave like a particle, it will landed on the screen as two peak, which is proportional to the possibility that this photon goes through these two slits, right? That's a just basic particle possibility. This photon can also act as a wave. In that case, you will have interfere of each other. It looks like something like this, right? And who decides that this photon gonna behave one or the other is the observation. So if I put a detector here, if I watch which slit the photon actually goes through, it will collapse into a particle pattern, become like this. If I don't watch them, it will become like a wave. Based on that, there are some very interesting experiment has been done. One of them is they leave the detector on, but they just don't collect data. So the detectors keep reading data, but this data are not going anywhere. This devices has been shut down. So even the device detector is on, no one have any knowledge about the entire system. Guess what will happen? It will behave like a wave, right? Some other people have done the delayed quantum double slit experiment. Basically, what they did is they move the detector behind the screen to let the photon make the choice first, then observe it. But it's very interesting. The photon will predict that it will be observed. So the photon will decide to act like a particle or wave ahead of time. So that's called prediction. you can check that video. It will tell you very clearly. Okay. So this is the implementation application. How I can use this prediction into this real world problem. Okay. Think this way. If this have a detector, I keep the detector on. The detector is sending data as a string 1001, those data bits, into a database, right? At the end of here, at the end of the database, there is a switch. If I switch off, the data will not go through. It will just go lost, just lost. But before the data actually reach this point, this photon is already go through the detector. It's already went through the, the slit. Probably it's already landed on the screen, while the data is still transmitting in its pathway. What does that mean? So if I just read the pattern, I can predict further downstream if this pathway is still connected or not. So that's how this prediction is coming in. What I will do is I will reading those data as those bits. So 0 means data coming from this slit. 1 means coming from that slit, right? So those data, those slit, those 1-bit information, I will feed at the app server. So when the user have a request, regular request, this request is usually serialized as a big object, right? To transmit this big object. In front of the object, I will attach a package. This package have 1 byte, right? This byte is exactly the information I read from the detector. I attach to this object. I call this detector. So every request from the customer, from the user, will become an object with a detector attached in front of it. And those information will transmit as a whole through the pathway and goes to our destination that I worry about. Now that's a system. If this system going to go down, for example, going to have a problem in 5 minutes in future, okay? If that's going to go down in 5 minutes in the future, the photon probably is already landed on the screen. The photon will understand, will predict if this detector information will eventually landed on somewhere that people can have knowledge on me or not. If they're going to have a problem for that system in 5 minutes, then the detecting information will not be successfully landed on that destination. So people will have no knowledge of which slit that I have been through. Therefore, I will decide to show a wave pattern. And this is happen 5 minutes before the actual happens. So this is how we detect that. Obviously, when the data landed on the database, I will separate this package to a separate database. Just keep that archive. There you go. That's how to use a quantum mechanic to predict a real-world story. Still working on it, but keep you guys updated. All right, thanks.